I'm not going to put everything. Some of the things are going to fall off. But I'm going to put some of the things that we have concluded. So what's something, Julia, if we had a total of 2 random variables added together, how do we decide to find the mean of that?
You add the means.
So you just take the old mu's, the old means, and add them up. So the mean is not mean. It's very cooperative. All right, what about the standard deviation of a total? How did that work, Caleb, when we switched to x plus y? We'll do x minus y next. It's the right color. Okay, a little tight, but don't rip it. Okay.
I
Just take it off.
Do you want to try mine on? It's looser.
Yeah.
Yeah, it's
What
like
would
this
you
thing
wear?
crap, it's stuck.
here.
Uh-oh.
I can do it.
Don't rip it.
He rips my sweater.
Yeah, you have to give
It
Julia
wouldn't be the first
one.
time.
Yeah, Julia will take mine.
Oh, that's lovely. Lovely. All right. We're getting warmed up in this freezing room.
It's not about. Okay. I can't get my shoulder.
Keep
I can't get
going.
my shoulder through it.
It's
Uh,
wide
Just
though.
wrap it like around
Yeah, it's
you.
wider than
Just put it
mine.
on with the arms.
Yeah, but it's not about how wide it is.
You don't have to
I can't
put
get
the
my
arms in it.
through the sleeve all the way.
Yeah, you could just wear it like
Just
a
wear it
scarf.
around like a
It won't
like
fit.
a
Yeah.
I can't go
shawl.
any further than that.
Wear it like a
Uh-oh.
shawl.
Okay, I don't want to rip it.
Just wear it like a shawl. Like wrap it.
Yeah,
just
wrap
don't
it
put your
around
arms in
like
it.
an old lady.
I don't know. I can't get my shoulder through it.
Just wrap it around you like a shawl.
Yeah. There you go.
Bigger than
Yeah.
us.
There you go. All right,
It's on
Caleb.
ours better.
What? How do we do the standard
that one.
deviation? Caleb.
Oh,
Caleb.
it's fine. It's fine.
All right. How do you do the standard deviation of a
Standard
total?
deviation would be a square root of standard deviation of x squared plus the
Not the
standard.
standard deviation.
I'm sorry, the variance. Wait,
Well, yeah, the standard deviation squared.
Wait,
so-
yeah, that's what I
okay,
said.
you're right. So the old one. All right.
yeah, squared.
Okay. All right. Then we went to the difference.
Thank you.
So it's not the total. We called it the difference. So how did that work, Elena? When we looked at a difference, how did we get the mean of a difference of 2 random variables?
We do. It's the expected value of the difference equals expected value of x minus the expected value of y.
Okay. And Bailey, how about the standard deviation of, not the total, but the difference between 2 random variables?
The standard deviation or the variation? Oh, the standard deviation of a difference is just the standard deviation.
It's just what?
The standard deviation.
No, because we got, which one? Would it be X or Y? We've got 2 of them floating around. So we've taken, it's sort of like the Jeep tours. We had Pete's minus Aaron's. Remember that discussion?
Yeah, I just thought that we were doing variation and mean for that.
Then we went to, all right, what's the variation then? All right, I've changed
Variation
it
of
to
x
variation.
plus variation of y.
All right, isn't that astounding? When we're subtracting, it ended up being the addition. All right, so if I did not conclude then, Bailey and everyone, then how do we get from the variance to the standard
You
deviation?
take the square root.
All right, so you take that sum, and remember, it's even though we're working with the difference, it's a sum, and you take the square root. I thought I did that, but maybe I stopped short of it.
I guess
So-
I could have just figured it out.
Okay. All right. So that is the conclusion from last day's work, and we're going to pick it up there. Do you have room to keep taking notes on that sheet?
No.
No? Not much room?
That's the whole
All
bag.
right.
I used all of the back and the front.
All right, I don't have any other paper, but you can stick your own paper there. It's not a whole lot. I guess I'll get you some blanks. Hold on.
I think
I'll
I
get you
have
some
one
blanks.
paper in the last chapter.
I just like to keep them there. So when I go back to study for finals, I like to put one at each.
Wait, are you in papers?
paper, but it's too thin. It's not 8.5 by 11. It's 8 by 10.5.
Out of paper anymore.
Hey, do you care if paper is 8 by 10.5 instead of 8.5 by 11?
April 8, 11.
All right, who wants a paper, plain, a new paper? Bailey, you have enough room? You have enough room?
Can I say like,
I'll use this.
Elena, you need more room? Okay. Alrighty. Continuing on the same, behind the 4 notes, let us notice this, and this will help us. RV is for random variable, and I want you to write down that if x is normal,
okay, if you need one,
then y is normal. When we say normal, a normal distribution, the hill. If the x variable is normal and the y variable is normal, it probably does not astound you, but we still want to make a note. The total x plus y,
what's RV mean?
a random variable.
I have a question.
Uh-huh.
Doesn't X stand for random variable?
Yeah, and y is a different random variable. So we have like Aaron's scores and Pete's scores. Okay. So we have a random variable x and a different random variable y. We're adding them up and we're calling it a total. Does it surprise you that if these are individually normal, their sum is also normal? It is, and the book goes ahead and actually plots them. If you're interested to see those, they're there for you. I didn't want to take the time. I didn't think it was a stretch. The difference, guess what? Do you think it's normal or not? Suppose we have the difference being x minus y. So do you think that will be a normal distribution? Any guesses? It is. So we can't really assume just because a random variable is normal that their sum is, unless you're shown or taught that. So there you are. All right. Let's put this together with a grand finale example. So you'll be practicing the difference here and the normal, the fact that these are normal, the difference and the total are normal. Let's look at, have you ever been to a fast food restaurant or any restaurant where the cup has to situate, a lid has to situate on the cup and it doesn't fit exactly?
Yeah.
Like it's too tight, you can't quite pop it on, and you think it's popped on, and then it spills in the car. It's so aggravating. All right, so let's look at some cups. We'll look at some cups and see how they work. See if they work or not.
You brought us cup?
Yeah, joy, cups, wow.
Oh wait, and we get the, and they're like coffee, and they're reusable.
What's even better?
Wait, no, they're not.
That's recyclable probably.
Anything can be reusable.
Let's do the sack first, and then we'll talk about putting something in.
Yeah, but
All right.
I mean like
right.
paper cups.
Paper not so much, these.
All right, try your lid, see what you think. And how you think of it.
Oh, they feel so weird. They.
Oh, it just.
Why is it?
What it?
Does it
The
fit?
lid just doesn't.
No, it fits.
Oh, wait.
Oh, good. I thought.
Okay, I thought you did it on purpose because it wasn't going on right away.
No, I didn't. I saw it. I want to order some cups where the lids don't fit.
Well, you could just put other lids in it.
Yeah, I thought
Look
you
up
gave
cups
it
on
Origins.
Amazon and then look for ones that have really bad reviews.
I feel like it didn't pop on, but I think no sleeve required because the outside.
Yeah, I really like
like
this cup.
Sleeve.
Baby. You don't even like put like a
Well,
sleeve
these
on it.
are on sale at Safeway. Buy one box, get one box free. So there you go. If you're
Welcome to
really
the
needing
cleaner
them.
world.
It's so pretty.
All
What's
right.
it made of?
So, taking notes with your cups.
Soy-based ink.
C is the random variable. It's the diameter of the cup. So I'm defining C as the diameter of the cup. And the mean, write this down, the mean of C is 3.96 inches. And the standard deviation of this random variable is 0.01. All right, so got it?
3.96.
3.96. And the diameter of the lid is another random variable.
3.96.
And the mean of the lid is 3.98.
Bless you.
And the standard deviation of the lids are 0.02 inches.
You sneezed.
So I'm going to,
I did.
because I want my lids to be slightly larger than my cups, or it's not going to work if they're exactly the same, or there's a big difference. So I'm going to do the difference of the
Do you want me to
two.
take the video, Allie?
Does that make sense why I'm doing the difference of
You're
the
not showing
two?
it. You're
And
not-
I want that difference, the lid minus the cup, I want it to be less than 0.06.
Sorry, Brandon, we're gonna hand it to Caleb now because Allie's not doing a very good job.
I think the lid would fit if the difference between the lid and the cup diameter is less than 0.06. We don't want it to be 0, so I'll say greater than 0. Between 0 and 0.06. Does that make sense? That's what they said. It makes sense to me. So, I want to know, after what we learned over here, what is the mean of the difference? So when you have two random variables that are subtracted, if you get it right, I'll put something in your cup. I don't know what, but I'll find something. All right. I'll fill up your cup.
My cup's overflowing.
Yeah, I'll overflow your cup. Hopefully not. How do I get the mean? Who has a
No,
help?
no,
Allie, what do I do with
Good.
these numbers up here to get this number here?
You take the mean x, which is MC, which is 3.96,
Uh-huh.
and then subtract from that 3.98,
Okay, so
and
when
then
we,
you get
right, just like this.
0.02.
So what do we get?
Negative 0.02.
Is it negative? The mean of the lid, we want the lid to be, we want the
It could be positive or negative. It wouldn't matter, right?
lid minus cup. I think I want to change that.
Wouldn't it be cup minus lid?
Yeah, cup minus lid. Let's
And
do
then
cup
that would be
minus
negative.
lid. Sorry,
minus
sorry.
lid.
And then it's negative.
Because we want the cup to be a little bit wider than the lid. No,
We want lid minus cup.
It was right.
Yeah, and then it's positive 0.2.
All right, lid
0.02.
minus cup. You got me all mixed up.
0.02.
0.02.
All right, 0.02, which
Yeah.
is the 3.98. All right, all right. Standard deviation of the difference. Standard deviation of the difference. We only did one of these yesterday.
That's the same as the
been-
standard deviation of
The long
lid.
day yesterday.
0.02.
Why would that be?
I don't know, but it's the same.
No.
Sometimes
Remember
things feel like the
yesterday?
same day.
Yeah.
And yesterday never ended. I'm still.
That's another curly color.
Got an answer I can peek at?
Not yet, but almost.
Okay. We're doing, if you forgot how differences work, look over here. This is why I put that up. So what happens when you have the difference of two random variables? You got one? Let me peek at it. Okay, that's what I got.
Woo!
That's what I got. Anything else?
I was surprised.
Yep. That's what I got. How about you? Alright, you're on track, I think.
Now I am an attractive person.
Yeah. Alright. So plug in that number
He's trying to make himself more attractive
there,
by covering
and
up.
that number there.
It's just
And the
not,
square root of it.
yeah, I was gonna say it's
So-
not bad. It'd be very
From our
bad.
examination yesterday, we learned that you take the variance, which is this square, unusually plus the square of this, which is the
Actually-
variance, and then take the
actually,
square
I might do
root
that.
of it. What was it, 0.022, say
Okay, well-
4? Alright. Alright, one more with this, and then we'll put something in your cups. Alright, and let's hope the lids are working. Let's say I